All right, so more of the same stuff, really, honestly. This graph shows the cost for taxi rides of different distances. Predict the cost of the taxi ride that covers the distance, 6.5 miles. So the distance of 6.5, this is 6 right here. And so it'd be about right here, somewhere in here. And so we could look at the graph. It might be close to $16, but we don't know. So the first thing we're going to do is we need to find the equation of the line. And then once we find the equation of the line, we're going to let x equal 6.5 and plug it in, and it'll tell us the corresponding y value, because the y value is the cost. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. And we just plug it in. 15 minus 7 is 8. 6 minus 2 is 2. So my slope is 2. Just like before, we plugged that in with an x and y value. So they chose x sub 2 and y sub 2. And we get that the slope is 2 and the y-intercept is 3. So the equation of the line is 2x plus 3. And it says you could double check it. We know that the point on the line, for example, 8, what did they use? They said 8 and 19. So when I plug in 8 for x, I get 19. So what they're saying is 8, 19 is a point on the line. When you plug in this x value and this y value to this equation here, you're going to get 19 equals 19, so it's true. The equation's right. But the question is, how much is the cost for a taxi ride that's 6.5 miles away? Okay? A distance of 6.5. So we take that equation and we simply plug in 6.5. 2 times 6.5 is 13. 13 plus 3 is 16. So like Mr. Adams said, it's probably about 16. In other words, this point on the line is 6.5 miles, comma, cost you $16. Okay? Because here's the 16. That's it for example number 2. Let's try to do some on our own. Okay? So we've got some conceptual questions here, and I want you guys to do your best to help me answer this. So for reflection question number 3, it says, what if, suppose a regulation changes the cost of a taxi ride to $1.80 per mile plus a fee of $4.30? How does the price of 6.5 miles ride compared to the original price? Well, what does that tell us? What do you know? What whenever we see per something, what is that with regards to y equals mx plus b? What is this $1.80? Yeah, that's the slope m. And what is this $4.30? This is an initial fee that you pay no matter what. Yeah, that's the y-intercept. So I've got this equation that's y equals 1.8 times x. Are you guys writing this down? Plus 4.3. Well, what I need to do is I need to evaluate this, and I need to say y equals 1.8. What do I plug in for x? 6.5. 6.5 plus 4.3. Now, if you plug this in your calculator, I'm going to say 1.8 times 6.5, and I get 11.7 plus 4.3. What's that? If I add 4.3 to that. Yeah, it equals 16. So how did that compare to what we just did? It's the same price, right? in that particular case. Okay, because in the previous problem, we said it cost $16 to go 6.5 miles. Okay. Let's look at problem number 4. How can you use a graph of a linear relationship to predict an unknown value for y for a given value within the region of the graph? So let's think about that. It says, how can you use the graph of a linear relationship to predict an unknown value? Well, what did we do? What have we been doing with the graph? Say from, this is an example, from the graph, what have we been doing? We essentially wrote an equation. Write the equation. Y equals mx plus b. Then plug in the x value to get, yeah?
What is after, this is right though?
Oh, the EQN?
Yeah.
That's just an abbreviation for equation. Okay. Then plug in the x value to get, I'm going to say the predicted y value. So all of science and all of mathematics does this. So every piece of technology that you own, at some point in time, somebody said, let's compare two things. And let's see if there's some sort of mathematical relationship between these two things. And then let's make an equation so we can predict. And then let's do the math. So for example, you may not know this, but pediatricians can predict how tall you'll be as an adult based on how tall you are when you're 2 years old and you go for your second annual checkup. However tall you are when you are 2 years old, if you take that number and double it, that determines how tall you will be as an adult. And your pediatricians will tell your parents, well, they should be about this tall. And so my children are all within about an inch from that prediction. How did they know that? Well, they just measured babies and then went back and measured them as adults. And they say, hey, you know an interesting thing? When kids are 2 years old, they're about half the height as what they are as an adult. Okay? So that's, in your electronics, everything is done that way. Okay? One last thing, and then we're going to almost be done with this problem. It says, how can you use a table of linear data to predict a value? It's basically the same process. So I'm just going to say same as above. And just say write the equation. Now, I'm saying write the equation, but when Mr. Adams says write the equation, what am I saying? One, we're going to take 2 points, and we find m, which is the slope. 2, we take 1 point on the graph, or in this case from the table of value, and we find b, which is the y-intercept. And then what's the last step for making predictions? Yeah, we plug in an x value. And we get a y value. Does that make sense? All right, we're almost done. Let's move on to one more thing. So if you look at this, it says Paula's income from a job that pays her a fixed amount per hour is shown on the graph. Use the graph to find a predicted value. So the income earned at 2 hours. So if I go to 2 and I go up to the graph, where does that look like that crosses? 2, 30. So what does that tell us? That it's probably $30, right? I zoomed in a little too much on that one. What about 3.25 hours? Well, if this is 3, a little bit over here, 3.25, how do I figure that out? Well, I probably need the equation of the line. Does this go through the origin? Yeah. So if I already know that B is equal to 0, can I find the equation of the line? In other words, if I say M equals, I'm going to pick this point here, which looks to be 6, 90. If I say 90 minus 30 all over 6 minus 2, I get 60 divided by 4, which is $15 an hour. Right? That's what she gets paid, is $15 an hour. So then my equation, y equals 15 times x, or if I want to make a prediction, I would say 15 times how many hours? 3.25. How do I find that? On the calculator. So I'll race you guys. 15 times 3.25 hours, 48.75, right? So what's the total income for 8 hours of work? Oh, no, wait. Let me read that. It's 5 8-hour days. So if I, over here, this is 6, this is 8. Well, how many hours is that total? What's 5 times 8?
The answer is 40.
You're my Siri. The answer is 40. So now what do I do to find it? Well, I'm just going to plug it in. I'm going to say y equals 15 times x, but x is equal to 40. And what's that equal? 600. Any questions on that?